welcome to the first of 3 recorded videos for the Part A lecture notebook in Module 3. In this first video, we're going to focus on the first learning objective, which is about applying conditional and comparison operators to control workflow in code. The second video will discuss creating and applying user-defined functions to perform some basic operations that also incorporate conditionals and comparisons. And the third video will discuss the more nuanced topic of pass by value or pass by reference. In Python, most logical flows can be accomplished using the if, else if, else syntax. Now, else if is abbreviated elif, E-L-I-F in Python, but it is interpreted as else if. And you can have as many of these conditions as you want inside of a logical flow. So you would generally have if condition and then do stuff. And if you could have nothing else, if what you want to have happen is if something's true, so basically if this condition is true, stuff would happen. Code that you would write here would happen. And if you just want that code, the stuff that you want to do doesn't happen if this condition is not true, you just want the code to continue on, you actually don't need any of this other stuff right here, the else if or an else. That's completely optional. What is not optional for an if, else flow is the if condition. You need to start with an if condition. And you're basically saying if something is true, do stuff. And if the else was don't do anything, just continue on in the code, you would just have a piece of code that was if some condition was true, you would do the stuff, and then that would be it. Nothing else would have to be written. Python interprets everything in terms of indentation. So unlike other languages that use terms like end or end if, or perhaps make use of curly brackets to group together pieces of code where one statement begins and ends inside of some sort of if, else structure or a for or while loop, Python is going to interpret everything in terms of indenting. This is also true in loops, as we will see in a future lecture. Now, we can dwell on this point further or just simply see it in action. You will get used to this, and it makes Python code fairly easy to read. Now, before we do, one thing that I've noticed is that in Colab, the default indentation when you start writing a user-defined function, a loop, or an if-else structure is 2 spaces, whereas the community standard is really 4 for the indentation. To change that, you can go to Tools, and you can go to Settings, and then you can go to Editor, and then you see this indentation within spaces. Its default is 2. Maybe yours isn't, mine was, and I'm going to switch it to 4. And you should also check that like show line numbers is selected. For some people, I've noticed that that isn't selected by default. And then you save that, and so now when you're working, the indentation should be really the community standard of 4 spaces instead of 2. In order for us to start setting up conditions that can be true or false to control the workflow of a code with an if, else type of structure, we actually first need to understand comparison operators in Python, which are usually used to determine whether a condition is true or false. The evaluation of a comparison operator returns a Boolean variable that has a value of either true or false, which dictates the workflow. So just to show what that is, I'm going to go ahead and add a code cell right here. You could do this to yourself if you're following along. You could add a scratch code cell, but true, you notice how that turned blue there? If I just look at like what type true is, if I look at that, it's a bool. It's a Boolean, meaning it's either a true or false. The same thing for false. False. Here, I'll just ran that, and you see that the type is a bool. And then what you're doing when you're checking a condition is you're saying that, are 2 values equal? Are they not equal? Is one greater than another one or not? And then when you look at those comparisons, they're returning a true or a false variable. And if a condition is true, like in a structure here, if a condition is true, so it's going to check the condition should be set to return something that's true or false. And if it's true, it's going to go in and do the stuff that you're coding it to do. So I'm going to delete that now, but this true or false is what's returned by these comparison operators. These are Boolean operators. They're just values of true or false. The comparison operators are really best understood by an example as shown below and in all the code that follows. And if you scroll down, you'll see I have lots of different code that's showing if conditions are true, and then you start seeing how I'm checking, certain values or certain conditions, whether this A is equal to this B or whatnot. So in the code that follows, I'm going to set A to be 2 and B to be 3. Now you can change the values in the code, but for now, I would just say leave it as it is so that you understand what's happening with the code and what I'm writing here in this text cell. But feel free to maybe create your own code cells with variables C and D, assign them values, and play with the different comparisons that you can use to compare those variables. So if you use two equal signs, it's very important. Two equal signs is going to judge whether the two variables are equal on either side of that two equal sign. You need to use two equal signs. If you write A equals B instead of A equal B, that's actually going to assign the value of B to the variable A instead of comparing the values of the two variables. Remember this. You need to use two equal signs if you're trying to compare two variables to see if they're equal. Now, if you use an exclamation point before an equal sign, you are checking if the two operands, the two variables on either side, are not equal. The condition is true if the two values are not equal. So if A is 2 and B is 3, A is not equal to B, right? 2 is not equal to 3. So that would return a false. And so you can see exactly what's going on here. If I, again, just kind of make this code cell, and if I said A equals 2 and B equals 3, and then I wanted to check is A equal to B, then, right, it's returning a false, a Boolean type false. But if I say, well, is A not equal to B, and I run that, you see that that is true. All right, and at any time, again, you can input your own code cells and check, but I have quite a few examples below. Now, is A greater than B? False. A is 2, B is 3, 2 is less than 3. So A is less than B, which is true. Greater than or equal, 2 is not greater than or equal to B, so that's false. Now notice when you do greater than or equal, that right there is given by, you have the greater sign first and then the equal. If you want to check less than or equal, you use the less than sign first and then the equal. So basically, if you want to check if something is greater or equal, or less than or equal, then just put the equal sign second, right next to the comparison operator of the inequality, the greater or the less than sign. So you can also use and or statements to combine sets of comparison operators, and you can also add not to negate a statement. So this is all based on logic. You get used to it as you start seeing how different comparison operators are combined, or different conditions are combined. So we're going to see some of this in action below. So here I make A2 and B3, and I'm just printing right here. If printing A equal to B, right? And this is a comparison. It's not A equals B. It's printing A equal to B. So let's look at that. That's false. Now, just to show again, if I don't have two equal signs and I print A equals B, this is kind of a problem because I'm trying to print an action and it's trying to actually assign B to A. That's a type error. That's not going to work. But if I, let's say, just print, let me do it like this. Right? If I actually make A equal to B, then that's going to be true now because I've assigned B to A and now I'm comparing is A equal to B. And this is a problem because I'm messing up everything in my code. I just want to compare A to B. So I want to run that again. So now A is 2 and B is 3. I reran this code cell above. Now I run this, and of course that's false. So I want to print A not equal to B. That should be a true that is returned. And now I can start looking how to use comparison operators. So for instance, this is an if statement. Notice the indenting, notice the 4 spaces. And in fact, Colab's kind of nice as it shows these little center dots that are kind of invisible until you start scrolling over them. That's the indenting that I need. So if A is equal to B, if that's true, this should print that they're equal. Now, an important thing, I didn't talk about this yet, is the existence of this colon right here. This colon is important after you have a condition. If a condition, else if a condition, else, which has no condition because else is just a catch-all. Else is just anything else happens, do this. You need a colon. If you don't have the colon right there, there's going to be a problem. In fact, I'll just go ahead and show you. If I run this, like nothing will happen because this condition's false, so it won't print this statement. Let me just show you. Nothing's get printed because that condition is false. But let's say I just got rid of that colon right there and I run this. this is an invalid syntax. So I see a syntax error, and you see this little caret is pointing exactly to what's going on at line 2. It's expecting something there. So syntax errors, where you see this little caret pointing to something, it's like it was kind of expecting something to appear there that's not there. In this case, it's the colon. So I run that, and nothing is printed because A is not equal to B. So this condition is false, so this never runs. If A is not equal to B, which is true, then it will print this statement, which is exactly what should happen. It will say, hey, they ain't equal at all. I'm not using proper English, but who cares? Now, you can use a comparison operator to create conditions in an if-else statement. So I can say if A is equal to B, I can print, hey, them two variables be equal. Else, I could print they ain't equal at all. Kind of just, versions of the terrible structure sentences I'm having above in these previous two code cells. So instead of having to check, in separate if-else or if structures, like if A is equal to B, print something, if A is not equal to B, print something, you kind of look at this going like, well, geez, if A is equal to B, then I should maybe print some output saying that. Else, like if this condition is not true, there's only one other thing that could happen, which is A is not equal to B. So I can just use if else, and again, look, there's else with the colon, and this is equivalent to kind of putting both of these statements together, running them back to back. But it's more compact. It's one compact piece of code. Now you don't need to write, again, you don't need to write elif A not equal to B here, because these two conditions are mutually exclusive. If A is equal to B, then basically this condition can't be true. And if this condition is true, this condition can't be true. And I'm basically just saying if this is exactly equivalent in this case to this if else. And if you can write shorter code, you should write shorter code. And so this is saying if A is equal to B, print this. Otherwise, you know that they're not equal. You don't need to check. There's nothing to be gained other than wasting computations that these two things are equal. So this should print they ain't equal at all. That's exactly what it prints. And then again, you can just check, is A greater than B? So I'm just printing the Boolean variable. So that is false. 2 is not greater than 3. But then I can ask, well, is A greater than B, or A is not equal to B? Okay. So if I check that, that's a true. So let's think about that. A greater than B is false, but A is not B, which is true. So if you have false or true, if you have a collection of or statements, only one of them needs to be true for the whole thing to be true. That's what we're showing here. Now, if I have a collection of and statements connecting different conditions, all of them need to be true in order for the output to be true. So this one is false, this one is true, the output should be a false. Now, I know that the issue here is A is not greater than B. So that is a false statement. If I put a not in front of it, then that's going to negate the false. So if it's not true, then basically if this is false, I want it to return a true. That's what the not does. So now this is true and true. And there you go. Now it's true. So play around with this. It's logic. If you haven't been exposed to logic and truth tables before, you just need to kind of play around with it a little bit to get the hang of it, but it's basic rudimentary logic. So you can create your own variables like C and D. I kind of recommend doing that so you can leave what I've done kind of untouched. But create like variables C and D, play with the values of them, and look at these different types of conditions to compare them, and start combining and or and not statements with all sorts of combinations of them. I highly recommend that. In the last part of this video, I'm just going to go over some more examples of if-else type statements just so you can get some practice. And again, I highly recommend making your own code cells with variables C and D with different variables and making your own types of comparisons of conditions and also combining those conditions into a string of like if-else, if-else-if type statements. So again, if you have an if statement, an if only statement, that's what you need. Like if I have if A is greater than B, print A is greater than B. Now, again, A was 2 and B is 3. So this is not true. A is not greater than B. Now, notice I can just write it like if A greater than B. I don't have to put it in parentheses, but it's often nice to put those statements in parentheses just so you can group the logic, especially if you start combining things. If I wanted to say if A is greater than B or A was equal to B, I prefer to write it with the parentheses because I think it's just so much more readable as code. I'm basically saying if this statement or this statement is true, then I would, well, printing A is greater than B, I should probably change what that is, or A is equal to B, something to that effect. That's great. Now this is a really, kind of unnecessary statement. This is just illustrating things. If I wanted to do that, I'd have A greater than or equal to, let's say, B, and then I could check that. I was just illustrating there, so again, this is here. I like to space it out that way. This is just an illustration of what I was showing of how you could combine statements and how I really recommend combining the different conditionals using parentheses around each, conditions, use parentheses around each condition. I think it just makes the code so much more readable because you can say with the parentheses, oh, it's if that condition or this condition. If you look, I'm going to go to Control Z and just kind of put this back here with everything. If you didn't have the parentheses here, so I have if A is greater than B or A is equal to B. If you look at that, to me, this is harder to read code. Like I have to pause to read it carefully because there's no natural grouping of things with the parentheses. And so you have to I think it just makes it so you have to read it slower. And I think there's value in adding these additional parentheses when you have multiple conditions inside of an if or else if type statement. When you're checking multiple conditions at the same time with ors and ands, I really recommend putting each of those conditions in parentheses. That's my own personal bias. You obviously don't necessarily have to do that, but I think it makes the code far more readable. And just to show, like if I run this, of course, nothing will print because 2 is not greater than 3, and certainly 2 is not equal to 3. But that ran, and if I got rid of the parentheses, you'll see it would, I believe it will also run. So, it's not necessary for you to do this. But again, I just think it's more readable the way I was suggesting. And I'll just go ahead and change this back. Remember to always have that colon there. And I'll just go ahead and change this just so that it's a little simpler. All right. So that's an if-only statement. And I mean, like, there's only an if here. And so basically, this line of code never executed. This was false and it just moved on. And you can just see that, like I could just, print here, hi, and it just moves on. Basically, if this is false, this, this doesn't run, this third line of code doesn't run, and it just continues on with whatever the rest of the code is. So that's fine. That's executing exactly as it's intended. And let's go to the next statement. So I'll just go ahead and get rid of that. So what about an if-else statement? If A is greater than B, then I'm going to print A is greater than B, which we know is not going to happen because A is 2 and B is 3. Else, which is what we know is going to happen, because if this is false, the else statement just runs if everything else above it fails. If every other condition that was in part of the if structure was false, then the else condition would run. So this is going to print A is less than or equal to B. I'm using a little bit of tech here inside just a print statement. And so then that just prints A is less than or equal to B. And I'm just writing it assuming that the person that's running it understands what that symbol means as A is less than or equal to B. And then I have an example of an if-else statement. So if A is greater than B, then I print this. Now again, notice you have all this indenting. You need all that indenting. So if A is less than B, then print A is greater than B. Else if A is less than B, print A is less than B. And then otherwise, what's the only other thing that could happen? They would both be equal. Right? And if I didn't want this, I'm just going to do a cut there. So if I just ran this right now, it's going to print A is less than B. All right. But let's just say for right now, I'm just going to go ahead and change this. Let's say I make A equal to B. Okay. Just running that right now. Now nothing runs. If this condition was true, which it's not, it would print this. So this is basically if false is how that reads. So this never runs. And then it's like, well, else if A is less than B, but A has now been made equal to B. So this is no longer true either. So that doesn't run. So if this condition, else if this condition, and then nothing happens. Nothing runs at all. So if I wanted something to run there, if I actually wanted some piece of code to run, then I would have to have that else there, that I would print they, be equal. I'm using improper English as kind of a joke here. So you see that runs there. But I'm going to go ahead and scroll back up here just to run this code quickly. A is 2 and B is 3. And now I'm going to run this. And you see A is less than B, right? So basically, as soon as this a condition is meant to be true, or then that part runs, nothing else happens after it. So here's an example of an if, else if statement. I'm just adding more and more else ifs. So if A is greater than B, which we know again is not true, print this. So this will not run. Basically, this will be false. Else if A is less than B, which we know is true, 2 is less than 3, it will print this. Now, A is also greater than 0 and B is also greater than 0 because 2 is greater than 0 and 3 is greater than 0. So both these statements are true. Now, what you won't see is this statement, printing A is greater than 0, or this statement, B greater than 0, printed to screen. Because the way an if-else-if logic structure works is as soon as a condition is true within there, it runs that piece of code. The first one that's true, it runs, and it doesn't run any of the others that follow it. That's a very important thing to learn and keep in mind. So you notice it printed A is less than B, and it didn't print these other true things. If I wanted these to print all these different cases, I would need to add, if I wanted to say, hey, print A is less than B and check that A was greater than 0, and check that B was greater than 0, and I wanted all of that, I would need to start combining these statements. And again, I like to do it with parentheses, maybe like this, A is greater than 0, and B is greater than 0, and then I would maybe change what was printed here. This is where you might say, boy, I wanted to check actually all of these things to be true, and I wanted to print all of that. Then you might have a lot of conditions that you're checking inside of all of your if, else, if type statements. So I just wanted to make that point. The main point here again is that if you have a condition that's true inside of your if, else, if tree of logic that you've written down, then as soon as a true condition is met, that code associated with it, the stuff you want to run, is run, and nothing else in the if-else structure is run after that. It just skips over all the rest of the code. That is what this block of code is demonstrating. And then finally, before the activity in the end of this video, an example of a nested set of if-else statements. So notice, I could say if A is greater than or equal to B, maybe what I want to then check, if that was the case, was, well, was it that A was greater than B or that it was equal to B? So in that case, right, notice I start indenting and then I start indenting again because it's part of an if-else statement, this sub if-else tree within the if statement. And I could have a bunch of if-else-if type statements in here if I had interest in them, like maybe I also want to check is A greater than 0, B greater than 0, whatever. This is kind of just a toy example that I'm using here, so nothing's really that interesting, but you could go ahead and play with this, and again, I recommend doing it with your own code with like a C and D. But this is not going to happen. None of this code will run, none of this will ever execute right here, given the value of A and B being 2 and 3 respectively, so it'll just go ahead and print this. But if you change it, if you change A to be 3 and B to be 2, then this is going to be true, and then this will be true, and then it will print that. It will then not execute any other part of the if-else structure, and because this condition was true, it won't ever go to the else condition or anything else associated with this outer if-else-if structure. So if I just run that, you'll just see it printed A is less than B. So that's it. That was a lot of details to take in about comparison operators, conditionals, nesting, the indenting. You might want to watch this part a couple times. And again, I highly recommend you do it for yourself. Do it with some variables C and D, just get some practice and make sure that things are printing out the way you want them to print out.